And the question is, two protons A and B are placed in between the two plates of a parallel plate capacitor charged to a potential difference V as shown in figure. The force on two protons are identical. Friends, we can see that this is the uniform electric field. Then we can draw that these are the electric field lines and this is uniform electric field. And we can find out the value of electric field inside the plate, as suppose there is a point and at this point the electric field due to this positive charge plate will be E1 and due to negative charge plate it will be E2. So we can write that the net electric field E will be equal to E1 plus E2, and we know that E1 is sigma by 2 epsilon naught plus sigma by 2 epsilon naught, then it will be equal to sigma by epsilon naught. That means this is the value of E, which is equally and uniform in this between the plates. So we can write that the force on proton F will be equal to QE. Friends, Q is same for both protons and E is uniform as we have discussed. That means both proton has the same force, then force on two protons are identical. This is true. Thank you, friends.
Hello everyone, the question is to capacitors A and B with capacities C1 and C2 are charged to a potential difference V1 and V2 respectively. The plates of capacitors are connected as shown in figure with one free wire to from each capacitor. The upper plate of A is positive and that of B is negative. An uncharged capacitor, there is an uncharged capacitor of capacitance C3 and lead wires fall on the free ends to complete circuit. Then here are options. This is the question figure for which it is given that capacitor A have capacity C1 and it is connected to a potential difference of V1, and capacitor B have capacity C2 and this is connected to a potential difference V2. It is also given that upper plate of capacitor A is positively charged and upper plate of capacitor B is negatively charged, and both the upper plates of capacitors A and B is connected to a uncharged capacitor having capacitance C3, and lower plates are connected by a free wire. Now we have to find, first of all, we will find the initial charge which was there on the plates of capacitor A and B. So, initial charge on capacitors. Let's say QA is initial charge on capacitor A. QA will be equals to C1 into V1 and QB is the charge which was there initially on capacitor B. It will be equals to QB equals to C2 V2. The charge on upper plate of capacitor A will be plus of C1 V1 and charge on lower plate will be minus C1 V1, and charge on upper plate of capacitor B will be minus C2 V2 and on lower plate it will be plus C2 V2. Now consider this A and D plate as a system. By considering A and D as a system, let's say this plate A and D forms a system. So the total charge on plate A and D will be conserved. By writing down, by considering plates A and D as system, total charge on both the plates will be conserved. Total charge on both plates will be conserved. So plates A and B have a charge of C1 V1 because there was initially no charge on plate D. So total charge on total sum of charges on A and D is C1 V1, which is given in option 2. Now consider the plates B and G as a system. By considering B and G as system, by considering plates B and G as system. Again, total charge is going to be conserved. Total charge will be conserved but the charge on plate B is minus C1 V1 and on plate G it is plus C2 V2. So total charge will be equals to C2 V2 minus C1 V1. Total charge, total sum of charge on B and G is C2 V2 minus C1 V1, which is given in option number 3rd. So option B and C both are correct. So option 4 is correct for this question and all other are wrong. Thank you.
Hello everyone, let us start with our question. In this question, what is given? The capacitance of a parallel plate capacitor with area A and separation D is given as to be C. Now the space between the capacitor is filled with two wedges of dielectric constant K1 and K2. Okay, we need to find the capacitance of the resulting capacitor. So here it is K1. So here it is given as to be given. We just write here is K1. Okay, and here is our K2. Now we see that the thickness of the K2 as well as K1, these are varying. Okay, so we cannot directly calculate the capacitance, resulting capacitance. What we need to do, we just need to take a element here. So if we draw, let's say this is our plate, one plate, and this is, let's say, the bottom plate. Okay, now here they are separated from this section. Let's just join a diagonal line. Okay, and here is the potential difference which has been applied. So for example, if we take a small a capacitor, okay, a small capacitor, let's at a distance of x, we just draw a thickness. Okay, let's say this thickness is dx. Okay, this is the thickness. Okay, now it is at a distance of x from this edge. This is the distance x. Now let's say from here to here the portion is y. Let's say this is y and total distance is d. So this would be d minus y. This would be d minus of y. And what would be the total length from here to here? The total length, let's call it as to be L. This is our total length from here to here. Now if we check, for example, if we take this angle as to be theta, and if we take the value of the tan theta, so what would be the value of the tan theta? So we can say that our tan theta would turn out to be, tan theta would be perpendicular by base y divided by x. Okay, and in this bigger of the triangle, if we take this as to be the bigger triangle, so this is our d divided by the total distance is L. So we can say that our x would be equals to y times L divided by d. This would be the value of the relationship between x and y. Similarly, if we differentiate this equation, then we can say that our dx would be equals to dy multiplied by L divided by d. This is the thickness and this is the derivative d. Okay, now what we need to do, we can just find that there are two capacitors, one this and one this. So we can take this, these will be in series. Okay, if we apply a potential difference, so they would be in series. So we can just make these two small capacitors. So let's say this is our one capacitor and this is our another capacitor, and these are connected in series and these have been applied with a potential difference. Okay, this is our one capacitor, this is our second capacitor. So that in the upper part it is given as to be K2. So we say that it is our K2, this is our K1. So the small capacitance of this portion would be DC2 and for this portion it would be DC1. Okay, so if these are in series, what would be the equivalent capacitance? So we can say that for series connection, the equivalent capacitance is given as to be 1 divided by DC equivalent. Okay, it would be equals to 1 divided by DC1 plus 1 divided by DC2. Now what would be the value of DC1 and DC2? We know that DC1 would be equals to, how is C given? C is basically equals to epsilon A divided by D. Okay, epsilon A divided by D. Now if we are having a dielectrics, so it would be K epsilon A by D. Now for DC1, what is the dielectric? It is K1. epsilon is epsilon. What would be the area? Area would be what? Area is this area. Okay. If we just draw this, and for example, if B is the width, then this is the area of the capacitor. If B is the total width, then area would be B times dx. So we put the value as B times dx divided by the thickness of the capacitor. For this C1, we can see here one of the thickness is y and one of the thickness is d minus y. So here it is y, and similarly for dC2 it would be K2 epsilon B dx, but the thickness would be what? Thickness would be d minus of y. Now we can put these these terms into this equation. We call this as our equation 1. Now if you put this, what would be the resulting equation which we would be getting? So it would be 1 divided by dc equivalent. This would be equals to, we just write y divided by k1 epsilon b dx plus y divided by, sorry, it would be d minus y, sorry, it would be d minus y divided by k2 epsilon b dx. Now there would be some common term which we can take it to be common. So 1 divided by dc equivalent. So what are the common term? We can take it to be outside. It would be epsilon b dx, and then it would be y divided by k1 plus d minus y divided by k2. So if we take the LCM, so LCM would be k1 k2 here, and the final after taking LCM and the common term, 1 by d equivalent would be 1 divided by epsilon b times dx. So after taking common this LCM, so it would be k1 k2, then k2 would be multiplied here with y, and here k1 would be multiplied by minus y. So if we take our y to be common, so it would turn out to be k2 from this side and minus k1 from this side, and then it would be d times k1, then whole divided by, this would be divided by k1 k2. Now we can write our so we can take the reciprocal, so it would be dc equivalent. So it would be equals to k1 k2 epsilon b, then we just write dx divided by this term. This term is what? Y times k2 minus k1 plus d k1. This is our term. Now we have already calculated the value of dx here. So dx is equals to dy divided by L minus d. So we can just write our dc equivalent once more. So it would be k1 k2 epsilon b. Then what is dx? It is L divided by d. So we just write L divided by d, and we take dy onto this side. Then it would be y times k2 minus k1 plus d times k1. Okay, this is the term. Now what would be b into L? B into L would be what? This is the total length. L is the total length and b is the width. So what is b into L? It is the area of the this plate. Area of the plate would be b into L. So we can just write in place of b into L as a. Then our c would be defined as the integration of dc equivalent. And what would be the common term? We just take it to be outside. Then it would be k1 k2 epsilon. Then b into L, it would be the area divided by d, and we can integrate this term, dy divided by k2 minus k1 y plus d times of k1. Okay, so what is the limit of y? So if we see, y would be varying from here, y would be 0, here y would be equals to d. Here we can see that y would be 0, here y would be equals to d. So we can put the limit as 0 to d. So limit would be from 0 to d. So it is a simple integration. So the answer would be in terms of log ln. So c would be equals to k1 k2. We just write once more k1 k2 epsilon a divided by d. What would be this integration? It would be ln k2 minus k1 y plus d times k1. So it is a linear function in the denominator. That is why it is the integration, and we can put the limit from 0 to d. But there is a coefficient k2 minus k1 for y, so we need to divide it by the coefficient. So we are just writing the coefficient here, k2 minus of k1. Now if you put the limit, what will happen? So our c would turn out to be k1 k2 divided by k2 minus of k1. Then it is epsilon a divided by d, and now it would be, we can put the limit. So ln k2 minus k1 into d. If we put the value, so what will happen? So there would be minus k1 into d, and there is plus k1 into d. So this term would be cancelled, and it would be k2 d divided by, if you put the value as 0, so this whole term would be gone. So it would be just d times of k1. So from numerator and denominator, this d thickness would be gone. So it would be c K1 K2 divided by K2 minus of K1. This is the one term. Then epsilon A divided by D. Then ln K2 divided by K1. Okay, so this is the final expression for our capacitance. K2 minus K1 K2 divided by K2 minus K1 epsilon A by D ln K2 divided by K1. This is the final capacitance of our question. Hope you understood the solution. Thank you.
Hello everyone. So the question is, two square plate metal of side 1 meter are kept 0.01 meter apart like parallel plate capacitor in air in such a way that one of their edges is perpendicular to the oil surface in a tank filled with an insulating oil. The plates are connected to a battery of 500 volt. The plates are then lowered vertically into the oil at a speed 0.01 meter per second. Calculate the current drawn from the battery during the process. So in this question we have to calculate the current drawn, and they have given us the dielectric constant of oil 11, epsilon naught is 8.85 into 10 to the power minus 12 per nm square. So this is our tank which is filled with the oil, and these are our parallel plate C1 and C2 and apart by a distance d which is equal to 0.01 meter. So when they are lowered in the oil, then the part which is covered with the oil is x and the remaining will be in the air. So that will be L minus x, the length will be L minus x, as x length is dipped in the air in the oil, and L minus x will be in the air. So now we will proceed with the solution. So they have given us L is equal to 1 meter, and the separation between the plates D is equal to 0.01 meter, and dielectric constant of oil K is equal to 11. EMF of battery V is equal to 500 volt. So we will assume that let at a time instant t length x of the plate be in oil and remaining length L minus x be in air. So the this configuration is equivalent to capacitor of capacitance. So value of C1 will be epsilon naught L minus x by D length, and the remaining length which is in the air, and the value of C2 is equal to K epsilon naught L x by D. So as it is given that they are connected in a parallel, so the value of C means equivalent capacitance will be sum of these two, C1 plus C2. So this will be equal to epsilon naught L by D. We have taken it out common. This will be L K minus 1 X L plus K minus 1 X. Now we know that the charge on the capacitor is Q, which is equal to C V, and the current through the circuit is I equal to dt I dt, and we can write it as Q equal to CV, so we can write it as V dc dt. So this value will be equal to V epsilon naught V by D, where value of small v is equal to dx by dt, and this is the speed at which the plates are being lowered. Now we will substitute the values. So the current I to capital V, this capital V, the value of this capital V is 500, EMF 8.85, value of epsilon naught into 10 to the power of L is 1, value of K is 11 minus 1, and the value of this means speed at which the plates are being lowered is 0, 0, 0 by D 0.01. Now the value of 0.425 into 10 to the power minus 9 ampere. So this is our answer. Thank you.